So we're on box 6, and it's another SMC Oscar. This time, luckily, with its 5-pin DIN intact. And I understand this is a pal of the other SMC Oscars that we did the other week. Now, I will use, because I left it out deliberately, our Oscar mic. So it's come with no mic or power lead, which is absolutely fine. So we'll do everything using our mic. So we'll connect it up to power. And we'll plug in the test gear. Let's see if it works as well as the previous one. No, nothing could work as well as the previous one, surely. Right, switch the power supply on and set it to 300 milliamps, 9 volts. No power overload. So we're at 160 milliamps. So we'll change that to 13.8 volts at 1.6 amps. 240 milliamps being drawn. So I'll get myself a piece of paper and we'll write down what it's doing. We'll use the back of this email, which is the Bury St Edmunds Car Club, so that's done with. SMC Oscar 1. I haven't forgotten opening up that one that I have bought somewhere down the line to find it full of modifications. We'll have to sort that out one day, but we need to get down repairs and we need to get on with that organ. So switch picture in picture on. At the moment it's showing a can of service on, which must be nicked off Mr. Chippy's bench. I better put that back. There must be a planet somewhere where all the applicator spouts go. Here goes. Transmit. Yeah, we haven't got any transmit. Oh, it's come up now. Is it the radio that's iffy on my mic? I think it's my mic. So it's doing, actually it's doing 4.4 watts, so it's going to have to come down. 27,79117 is virtually spot on. Deviation, wallow. 2.4 kilohertz, spot on. Receive. So receive is what? Good grief, this is good. .35 microvolts for 12 dB. cyanide. Now, because it's doing overpower, I'd be interested, because it's very rare I see this. It's doing 4.4 watts. What I want to see is it's doing 4.4 watts on all 40 channels. So we'll go to channel 40, and we've got 4.5 watts. And we go to channel 1, we've got 4.2 watts. So that's been achieved by ruining the balance, hasn't it? You never want to have these anything thrash. It's like driving your car at full pelt. Legality aside, it will kill it. The difference in range probably isn't even measurable. So get the screws out. I can't see any capacitor snags in that. I think we're going to be hard pushed to actually get better. Actually, the deviation, the way that's set with the other one, isn't ideal, so that's going to improve. So we're going to start, of course, with the VCO, and once again, of course, I'll have to get the instructions out. And as ever, I'm going to have to remember whether this is a floating chassis It doesn't look like it. It looks like it's negative Earth. So I know we go to channel 40 on these. And I know the test point is there, resistor 4, or is it resistor 7? Resistor 4 by the looks of it. And we know it should be 4 volts, it's 4.2. That's neither here nor there. And we're going to transmit. It should also be 4. Back to receive, into transmit, and then we go to channel 1. Should be between 1.8 and 2.5. There's our transmit. Didn't need doing, but I've done it and it's spot on. Selecting channel 20 before I tune it all up on the wrong channel. So we want peak, peak, peak. So far that's been spot on. See if we can get this final bit of balance done right. So we want maximum. It's 4.5. This started to drop as it heats up. So it's actually peak at 4.9. Make sure. I think we can just see 5 there. Yep. So sometimes, you know, we do this and the set will just do 4.1 watt, and it's really supposed to do 4.4, and then you balance it out. But this one is doing 5, so it's, you know, one of those which isn't the Friday afternoon set. So now this is where I have to get the service manual instructions. So L4 is clockwise for 4.4 watts. There's 4.4, and then L9 is anti-clockwise. They say to 3.8 watts, but we'll be doing it, of course, to 4 watts. We haven't got to worry about getting it through customs. So there is 4 watts. So let's see now what our balance is like. So on channel 1, 4.0 something. I was channel 40. Channel 40, 4.0 something. And channel 1, 4.0 something. Channel 20, 4.0 something. It's absolutely equal across the 40. So that's enabled us to tune that up spot on. Very pleasing. So we need the meter, for what it's worth, to read when I press transmit 4, which it does. Now low power, so it should have 400 milliwatts. It's doing just under 1 watt, so hopefully I can remedy that. There we go, 400 milliwatts. So I'm pleased about that. So far this is very, very good. So we'll just, I say the frequency isn't really worth touching, but we will do. So just leave it very, very slightly high. So it's got time to drop. Let's see what the current consumption is. 1.1 amps. So it's being efficient. I mean, sometimes they're 1.6 amps, and you know, which is where I set our current limit. And then the next one you come to, I mean, yesterday's Uniden was 997 milliamps at 4 watts. Very efficient. The day before's Amstrad was 1.6 amps. Deviation. So I've altered that because that wasn't kind of set right. Let's see where we are now. So just pop that up a fraction and see how that goes with the Wallow. Wallow. 1, 2. We need a bit more. Let's try it there. Wallow. 1, 2. Wallow. There we are. Right, so we'll go through the receiver. Yeah, this could be the set with the least wrong with it that I've ever seen. And that 0.35 microvolts is phenomenally good. So we want, I'll tell you what, we need to do the detector first, so we'll just do that. This could affect his clarity. So we've got 100 microvolts on the signal generator, and we want to get maximum recovered received audio. And the coil's just where the 5-pin DIN is. I'm going to have to use the wrong tool. I don't want to break the wrong tool. I'll tell you what, we've gained some ground for him. That will improve the clarity. So, bench light back on. S9. No, we want. Let's go over to the sign-up meter. Got reading of 4 dBs. Turn the volume down a fraction. I keep saying we don't want to saturate the FM receiver, or you won't be able to see any adjustments happening. You know what? We're gaining some. Right, we'll turn down the attenuator again to there. Let's try that one again. Well, I wouldn't have thought we could have got anything better out of this receiver, but we have. Just go onto there. And then there's one down here, right under the wiring. So we will now see whether we've got any improvement. There's 12 dB, and we'll read off the attenuator together. We've got 0.29. I think his powers was 0.27. So before we announce that as absolutely true, I'm going to change scales because we're not far off being between scales. And on my other scale, see, I've got 0.25. Let's call it 0.26. So it would be fair to say that could be 0.26. It's somewhere going to be between the two. I am between scales, so you're reading the top end of one scale and the bottom end of the other. So there you go. So he may have got the same result as his mate. But you know, not all Cybernet 134s are equal, and these consistently work right at the top of the ladder, really. You know, we've seen York 863s and Rotel 240s doing 0.9 microvolts, and then we see these doing this kind of 0.29. So that is excellent. So let's go back to having 100 microvolts on the signal generator, and we'll look at this S meter for what it's worth. It needs to read S9, it's reading S8 in a bit. You never know. You know, those little meters, they may have cost more than the big meters. So don't think you're getting half your money's worth. So it just leaves us with squelch. That's the multimeter telling me to turn it off. Squelch, well, let's turn the attenuator down to 0.3 of a microvolt and turn the squelch to full, just like that. And we want to do, I would like this radio to wake up when I get to 100 microvolts. So there we are, 0.3, 1, 3, 10, 30, 100. Spot on. Doesn't need adjusting. If it needed adjusting, it's there. That's one adjustment I haven't had to touch on this radio. So we're going to switch the signal generator to standby at 0.3 of a microvolt, and now we'll turn down the squelch and we'll set threshold. There's threshold, and let's see when the thing opens up. So let's have a look. So it's coming in at 0.5 of a microvolt. It's leaving at 0.45 of a microvolt. That's very good. A loss of sets, it's 1 microvolt. And at least you've got a knob, even if it's concentric and not one of these stupid menu driven things. Well, we're done. I think that's been the quickest tune-up we've done. And some of these I've spent 3 days on. And then we've spent whatever the length of this video is. I don't think I've paused the video. I think we've run continuously. Unplug the speaker, as in our test equipment, and the internal speaker is working. And we'll put the screws back in and pop it on the air. Tomorrow, I say, well, the next time we're able to do CBs, which may be able to make a start tomorrow, it is a team base station, and the customer is quite excited to see if we can get this thing to work, because it's had fingers in it, and I think every coil in it's broken. Now, what we can do, I don't know. And is it he who sent a Shogun as well? We said we wouldn't do any more Shoguns because they're so bad. They were riddled with dry joints when they were new, and 40 years later they're riddled with more dry joints. So if it's the Shogun as well we're doing, well, we'll get Mr. Chippy to look at that. There we go. So I'll take it off the test equipment. We'll plug it in to the Antron 99 roof aerial. One on a Roger. There's no Rogers out there. It's about 3 o'clock on Thursday afternoon. Check it's transmitting promptly at the band edge. One on a Roger. Nobody out there. Good. Well, I'm glad there's nobody out there. It means that we can use it. Right. Well, we'll turn off the test gear, save some electricity, and thank you for watching another SMC Oscar 1 from 1981 that once again works exceptionally well.